Hi, today we're talking about chemical reactions. So, in chapter 2, we talked about atoms and elements and things like that. We talked about the compositions of matter and we looked at all of those elements on the periodic table. And then in chapter 3, we learned about chemical compounds, how these elements and these atoms combine together to make compounds. Right? So we learned how if I give you some like sodium and then you have something like Cl, we learned how these combine to make a compound, right? And we learned how these depend on their charges, meaning they depend on how many electrons they tend to lose or how many electrons they tend to gain. And these come from, as we talked about, valence electrons. Now, we learned how to make formulas. So, sodium has +1, chlorine has -1, and we learned how that gives us, when you do the cross rule, it's going to be just NaCl. And that's table salt. But if you have a different charge, you're going to have a different compound, right? You're going to have a different compound. So if you have aluminum, for example, aluminum has a charge of +3, I mean. And then Cl has a charge of -1. So aluminum is going to need three Cl atoms. So it's AlCl3, right? So Na is NaCl. This is AlCl3. So we learned how to make these compounds and how to make these formulas, right? This is a chemical formula. Now, we also learned how to do this even when you have polyatomic ions, right? So if you have some like let's use sodium again, but in this case you have sulfate, which is SO42 minus. Then I ask you, what's the formula between these two? You're going to use +1, -2. If you do the cross here, you see that sodium will have to be 2, Na2, and then SO4 gets 1. And this is sodium sulfate. We'll learn how to do the chemical formula, whether you have atoms, elements, polyatomic ions, and things like that. And that is important. It's important because now that we know how to do that, then we go to the next level where, so the first level is you have atoms. The next level is atoms combine to make compounds, right? But turns out that in nature, these compounds combine together and they react together to make chemical reactions, right? So you have, we learn how, for example, you have, I don't know, let's do something pretty easy. Like you have NaCl, sodium chloride, right? That comes from Na and then Cl. And then let's say you have something like magnesium bromide, and this is going to be Br2 if you do the cross rule, right? So the atoms combine to make compounds, but also compounds react together in chemical reactions. All right. So by the end of this video, you should be able to tell me easily the answers to this question, but we're not there yet. So this chapter is about naming and predicting chemical reactions, right? This is what this section of the chapter is about. So what is a chemical equation and what does it contain? A chemical equation is going to show you evidence of a chemical change, right? When you take this and add this, it changes into this and that. That's the chemical equation, right? So the chemical equation will show you a chemical reaction, right? So you have a chemical reaction that's happening, a chemical equation will show it to you. Now, a chemical equation will have two main parts, and these are reactants and products. Reactants, of course, are things that are reacting, the starting materials, and the products are the things that you are producing. All right. So if you look at a chemical equation, this is an example, right? You're going to have things on this side which are reactants. You're going to have things on this side which are products, right? And a few other features of a chemical reaction is so they identify products and reactants, right? And then the reactants are going to be to the on the left, the products are on the right, and then they are separated by an arrow, right? So when you have a chemical reaction, you got to have an arrow in between that shows you that, oh, okay, these reactants produce these products, right? Now, sometimes, not always, will show the physical states of reactants, meaning is it liquid, solid, or gas. So, for example, here we put this in parentheses and it's solid, this is liquid, this is gas, right? Those are physical states. Sometimes you also show you will also show you a symbol that shows you this is a delta symbol. It shows you that energy is required. Energy is being used in the reaction, right? Or energy is used, or sometimes if it's at the end, energy is released, right? And the equation has to be balanced. That's why you see these numbers here. That's why you see 2 here, 2 here, so that we can balance the equation, and we'll learn how to balance the equation later. So this is these are the main things that happen when a chemical reaction is happening. But how can we tell that a chemical equation is happening? Well, there are a few ways we can tell that a chemical equation has taken place. This is in the lab, of course. So we can use visual evidences like the release of gas. So if you have an equation that releases a gas, you're going to see like bubbles. It's going to be bubbles in your reaction. You're going to see them going up. Uh, that's an easy way to tell that something is happening. You can form a solid or a precipitate, right? So that is your solution. You have a clear solution, you add another clear solution, and you start to see chunks of reactions happening. A easy like a something that comes to mind is when you have milk. If you ever added lemon to milk, you're gonna start to see chunks of things in there. That's precipitation. But that is producing something solid in there. Sometimes you can either produce heat or absorb heat during the reaction, and it's really cool to mix two things, and then before you know it, the test tubes start to get hotter. Sometimes you see a color change, but there are other ways that you can test the occurrence of reaction too as well. Uh, we can check in the lab things like electrical properties, absorbance, and things like that. But we have to have special machines for that. But the reason why this is important is because you have to have an evidence of a reaction occurring, right? Otherwise, how are you going to tell? But we not only can measure can tell whether a reaction is happening or not, but we have tools to even measure the amount of the products that we're producing, and we can measure to very specific details on what's happening within a reaction. But and we're going to measure this in this reaction, in this chapter as well. But before we get there, let's talk about different types of reactions. So, what are types of chemical reactions? Now, I'll tell you right now, there are many types of chemical reactions, but I'm going to show you about 8. All right, and we will mainly focus on 6, but I'm going to show you 8 types of chemical reactions, but I'll tell you that there are many more. These are the most common ones that we see in nature. Now, the first one is combination reaction. And it's exactly what it sounds like. You take one thing represented by A here, you add another thing represented by B here, and then you get AB together. All right. So I gave you an example here. All right. This is an example. Na plus Cl is equal to NaCl. And we'll talk about how to do that. The next one is decomposition. Decomposition is the opposite of combination. And you start with 2 things that are bound together, and then you separate them. AB equals A plus B. An example is our example that we started with. You have HGO. This is mercury oxide, and then it gives you mercury and oxygen, right? Now you'll notice something interesting happening here. Even though we're saying sodium plus chlorine, chlorine is being represented by Cl2, or mercury plus oxygen, oxygen is being presented by O2. And this is important because, again, for this video, you're going to have to be able to predict what's going to happen and how things are going to combine together. So these two have the little 2 at the bottom because some compounds don't like to be by themselves in nature. So when you have chlorine or oxygen or hydrogen, they come in pairs, they come in 2s, and we need to remember those. We call them diatomic atoms, right? Or diatomic elements. So there are a few ways you can remember them. So if you look at the periodic table, an easy way to remember them is to just draw it. It starts at I. So I here, and then they go to N, right? So it's this little arc here, and then hydrogen, right? 7 of them. 1, 2, 3, 4, 5, 6, 7, right? So NOFClBRI, and then you have hydrogen. These come in 2s. So whenever you're making an equation, for example, you say, oh, oxygen plus hydrogen. When you're writing down that, it's going to be H2 plus O2. But we'll talk more about that when we get there. I just wanted for you to notice it. Now, the next type of equation is called single replacement. Single replacement. And these replacement reactions are pretty interesting. You have one single thing here, and then you have 2 things here, and guess what happens? It's a replacement. One is going to come in and replace this, right? One way to think about it and remember it is, let's say you have a couple. You have a couple that's together, and then you have a single person, and then that single person unfortunately comes in and replaces one person in the couple. That's a single replacement, right? So when you do a single replacement, guess what's happened? That person that was there becomes single here, and then you have these together, right? That's one way to remember it. But you, this is an example. You have copper here, then you have silver nitrate, right? And then what happens is that copper is gonna come and replace silver, and then silver is gonna be by itself. Then you have copper nitrate. All right. We have to know how to do that, and that's a single replacement. Now, when it comes to double replacement, and another thing that I'll show you there in a minute, but you'll notice that we still, whenever we're writing down copper nitrate, we still have to follow our rule of writing down formulas. So you have to do the cross rule. But we'll do that more in the examples that we look at. The double replacement is going back to our example of a couple, then now you have two couples. Now you have two couples, and then these two couples are going to exchange partners pretty much, right? B goes with C, and then A goes with D, right? And then you make AD plus CB. It's a double replacement, right? So, and another, this is an example. You have PB and BR, and then you have sodium and chlorine, and then you're like, okay, it's a double replacement. So whenever I give you an equation, you have to be able to tell me what type it is, and you have to figure out what type it is before you try to guess what the products are going to be, right? So for this one, again, these are going to be together. The insides are going to combine together. Then the outsides are going to combine together, right? So PB combines with Cl, BR combines with Na, and guess what? You have to do the cross rule to figure out what they're going to give you. All right, other reactions. This is a combustion reaction, right? So these are reactions with oxygen. Whenever you have a carbon and a hydrogen, right? We call these compounds hydrocarbons, but whenever you have something that has a carbon and a hydrogen, right? And these are organic compounds. And an example is, methane gas, or, other things that are volatile. Whenever you add oxygen and a spark or something, they're going to always give you a CO2 and H2O. That is the rule. And I added X and Y here because it doesn't matter what number is down here. Whenever you have carbon and hydrogen, and sometimes oxygen here, whenever you add O2, it gives you CO2 and H2O. So an example is CH4 plus O2 is CO2 plus H2O. This is methane, right? Another example is rusting or corrosion. So the formation of corrosion is when you have a metal exposed to oxygen and then it becomes a metal oxide, right? We call this rusting or corrosion. So, we see it in iron. Whenever you take iron, you add oxide, you have iron oxide, and this is rust. So it's a rusting or corrosion reaction. And one thing that you notice is that the rusting or corrosion reaction is also an addition reaction, right? We're adding two things together to form one thing. So this is A plus B equals AB, right? So it's still also an addition reaction, but it's a corrosion or rusting reaction, right? Now, these other two are also very common reactions in chemistry, and this is called oxidoreduction. It's not reduction, it's reduction. Oxidoreduction reaction, right? But these are a little bit more advanced, but we need to know about them. So An acid-base reaction is when you have an acid and then a base together. The reason why I won't spend too much time on it is because we haven't learned about what an acid or a base is, and we're gonna have a whole chapter dedicated to this. But when you add an acid to a base, they give you water and a salt. Now, an acid, in this case, at least for you guys, is something that has a hydrogen in it. It releases hydrogen. And then in this case, a base has OH in it. And the base is also a hydrogen acceptor. So whenever you combine these two, they give you H2O, and then A combines with M, it gives you Ma. Now, if you've been following closely, you realize that this looks like something else. This looks like another reaction that we already looked at. What is it? It's a double replacement, right? It's a double replacement. It's a special double replacement that combines an acid and base to produce water and a salt, right? So this is called an acid-base reaction. It's a neutralization reaction. And an example is if you take HCl, which is an acid, right, plus NaOH, which is a base, they give you NaCl plus H2O. So Na combines with Cl to give you NaCl. Hydrogen combines with OH to give you H2O. All right. Another one is called an oxidoreduction reaction. And an oxidoreduction reaction is a transfer, it involves a transfer of one or more electrons, right? It's a reaction that involves a transfer of one or more electrons. And oxido it comes from oxidation and then reduction. So you have an oxidation and reduction, and oxidation is loss of electrons. Electrons. Oh, you can't see the oxidation part. Okay. Hold on. This is oxidoreduction reaction, which is the loss of electrons. Okay. So zinc, as you can see, it's zinc becomes zinc 2 plus, and as we learned in chapter 1, no, chapter 2, something with a plus sign means that they have lost electrons. So zinc loses 2 electrons to become zinc 2 plus, and guess what? Copper 2 plus gains those 2 electrons to become copper. This is a very basic oxidoreduction reaction, but we'll talk a little more about it, even though we won't go into that many details. Um, so for the other reactions, I want to go into a little bit more detail. So the combination reactions, because I want everybody to know about this, right? So you take one thing, you add something else, you have a combination, right? And sometimes that one thing will be a compound rather than an atom, right? Compound plus another compound, then you combine them together. But most of the ones that I'm going to ask you are going to be atoms, right? Now, I really want you to be able to predict, right? You got to be able to predict reactions. So let's look at an example. I think I have examples in the PowerPoint. So we started with NaCl. That's okay. We know how to do that. But let's say I have, yeah, we've already done NaCl. But let's say I have I give you, okay, let's say I give you, let's start easy, like magnesium, and then I give you Br. So it's like, what's the reaction between magnesium and bromine? First of all, you have to remember that bromine is one of those diatomic compounds. So bromine will come as Br2, right? Bromine comes in twos. You have to remember that. They come in twos. So let me help you a little bit. Again, we can use this table to remember them. Another way to remember them is this thing is say have no have no fear of ice cold beer. Uh, it's not an endorsement for beer, guys. It's just a easy way to remember. Have no fear of ice cold beer. It will show you HNFOICB, right? And if you remember that, you remember that whenever you have hydrogen, nitrogen, fluorine, oxygen, iodine, chloride, and bromine, you're gonna need to write it as a pair rather than a single. It's an easy way to remember it. Now, if I ask you, okay, then you remember that it comes in twos. That's number one. But number two, you're going to predict the answer. When you predict the product, first of all, you're going to be like, oh, okay, what type of reaction is this? Well, it's one thing plus another thing. It's A plus B, right? It's A plus B. So it must be a combination reaction. And guess what? We know how combination reactions go. They combine with AB. So you know that magnesium is going to combine with Br. But you have to remember, before you write down the answer, you have to write down, you have to see how magnesium combines with Br. So when you take magnesium combined with Br, you remember that, okay, magnesium is plus 2, Br is -1. So for this one, it's easy. It's going to be magnesium Br. Magnesium gets 1, Br gets 2. It's MgBr2, right? And we're going to learn how to do balancing, but this one is balanced. That's okay. But you have to remember that you have to always do the cross, because you can't just assume that, oh, this is gonna be MgBr. Because what if you have some like this? What if you have aluminum? Let's say aluminum, aluminum, and then oxygen, right? First of all, you have to remember that oxygen comes in twos or two, but then you're like, okay, aluminum, oxygen. Guess what? Some people are they really really want to write down that it becomes AlO2, and that is false. That is definitely not true, right? It's not AlO2. It's going to be, you're going to find out, okay, you know that Al combines with O2, but you're going to see like, okay, how does Al combine with O2? Guess what? We've done it in the last chapter. Al and oxygen, how do they combine? You know that Al has +3. You know that oxygen has -2. When you cross them like this, guess what we get? You get Al that has 2 on it, and oxygen has 3 on it. Right? So the numbers you have here for your reactants have nothing to do with the numbers you have here for your products, right? You still have to do the cross rule to find the formula. It's very important that everybody get this, because a lot of people are they get tricked into, like, I say like, oh, what about magnesium and oxygen? And then people, because oxygen is O2, they're like, oh, it's gonna be MgO2. No, it is not, because that's not how magnesium reacts with oxygen, right? Before you write down the answer, remember, before you write down the answer, you have to do the cross rule. So magnesium and oxygen are going to be +2 here and -2. And if you do the cross rule, because they're the same, they're going to cancel, and it's going to be MgO, right? Because that's what the formula is, that's what the rule is, right? So magnesium doesn't react with two oxygen ions, it reacts with one, not oxygen atoms, I mean. It reacts with one. And then after that, we're going to learn how to balance this. But I really want you to get this. And this is not just for combination, for all of them. All right, let's look at the composition reactions. The decomposition reactions, as we talked about, are the opposite of combination reactions, right? They start with AB and then they decompose into A plus B, all right? So start with HgO, for example, it becomes Hg plus O2. And that's another thing to remember as well. You have to remember that oxygen, when it separates, it still has its pair, right? Because you have the diatomics. So check this out. What if I ask you, like, okay, what does this reaction give me? H2O, like this, right? If I ask you this, you're like, oh, okay, they gave me two things, they didn't give me anything else. It must be AB that gives you A plus B, which is a decomposition reaction, right? So before you write down the answer, you're like, okay, hydrogen is going to separate with oxygen. Before you write down the answer, again, you have to remember two things. You have to remember the cross rule. You have to remember the diatomic rule. So hydrogen and oxygen are two parts. Both of them are parts of the diatomics, right? Remember, they have no fear of ice cold beer. H and O are all there, right? And here they are as well. They are diatomics, and because they are diatomics, when they react, right? When they react, they're gonna give you H2 and O2, right? Because both of them, they don't like to be by themselves, right? Plus O2. They don't like to be by themselves. That's why, right? And a lot of people, whenever they see something like this, whenever they see like H2O, they they might think that, oh, it's gonna be H2 plus O, but it's not, right? Because again, oxygen doesn't like to be by itself, so you have to give it its pair, right? That's how you predict decomposition reactions, right? If it's like magnesium, if it's a metal, right? So let's say you have MgO, the one that we already made. Magnesium is going to be by itself because magnesium is not a diatomic. And then oxygen is going to be 2. By the way, I keep mentioning it. These reactions are not balanced, right? We're going to learn balancing them later, but right now we're learning how to predict them, okay? Because if we had to balance them, we know we have 2 oxygen atoms here, but we have 1 oxygen atom here. So we're going to learn how to balance them. But you see how magnesium becomes magnesium by itself, but oxygen, because it's a diatomic, becomes O2, right? That's how we predict diatomic reactions, okay? All right. Not diatomic, decomposition reactions. All right, let's go to replacement. So single replacement, as we learned, is going to be A plus BC is equal to B plus AC, right? And the way it works is A comes in and replaces B so that B is by itself, right? And these are examples. You have copper by itself replaces silver, and then silver goes by itself, and then you have the combination, right? Now, let's look at an example because I want us to learn how to follow the same rules, right? So let's say you have aluminum plus calcium sulfate. All right, so as you can see, you look at it, and again, when I give you an example, I won't tell you what type it is. So you have to figure out what type it is. So if you look at this, you're like, oh, okay, this one is one thing, which is A, and then this one is two things, which is B and C, right? Then you're like, oh, okay, this has to be a single replacement reaction. And we know how single replacement reactions are. We're going to, well, A is going to come in and replace B. All right. So what's going to happen is aluminum comes in and replaces calcium. Calcium is by itself. And then you know that aluminum is going to combine with sulfate. But here is something that's very, very important. Before you write down how aluminum combines with sulfate, you have to do the cross rule to see how they combine, right? You can't just write down like AlSO4. That will not be true. You have to do the cross rule. So you have aluminum here, you have sulfate here. Aluminum is +3. Sulfate is -2. If you do the cross rule, it's going to be aluminum gets 2 and SO4 gets 3. You see how it's very different from AlSO4? But we know how to make the formula. But like I said, the numbers that you have here have nothing to do with the numbers that you have in the reactants. You have to get them from trying to find the formula. You have to do the formula again, okay? So don't, try to resist just writing it down as you see it. You have to work it out, okay? And that's single replacement. That's when you have a single replacement. Now, what if you have a double replacement? Well, it's similar to a single replacement, but it's different is that you have two things adding to two things, right? Whenever you see two things plus two things, it's a double replacement, right? And the general rule of thumb is that the middle ones combine together and then the outside combine together, right? So usually you have an ionic compound. Most of these are going to be an ionic compound, which is what we call a salt, right? For example, you have this one, right? You have two things plus two things, right? Or here, two things plus two things. And it's AB plus CD. And we need to be able to predict them. So let's look at something. Let's look at an example. Let's actually go back to the example that I gave you at the beginning of the video. All right. NaCl plus MgBr2. Now that you know what what types of reactions there are, you know that this is a AB plus BC, right? So this is AB plus B, not AB plus BC, AB plus CD. CD. All right? And we know that after this, we know that we're going to react. And the metal reacts with the non-metal, and then metal with the non-metal, metal with the non-metal. So the Cl in the middle will bind to the Cl will bind to Mg, the Na will bind to Br. Okay, so this again, the very, very important rule is that before you write down the result, you have to figure out the formula. So you say Na is going to react with Br, right? But how are they going to react? Well, Na has +1, Br -1, that's the charge. If you do a cross, it's going to be NaBr. Okay? No numbers. No numbers, right? Notice it has 2 here. Br has 2 here, but it doesn't have anything here. And again, it's because that's the cross rule here, right? A lot of people get tricked into writing it down as it appears in the reactants, but you have to get the new formula. Same with magnesium and chlorine. These are the ones that combine. So it's like magnesium here, chlorine here. So magnesium is +2, chlorine is -1. If you do the cross rule, it's going to be MgCl2. All right. So this is a double replacement, and this is how a double replacement works. And like I said at the beginning, you're gonna be able to predict the results to this equation, no problem, as long as you know the type of reaction and how all of this works. All right, so let's look at. Oh, before we look at the next type of reaction, there's something interesting that happens when we mix these reactions, especially when we mix salts, meaning these ionic compounds. We make what we call precipitates, right? So a precipitation reaction is a chemical change in a solution that results in insoluble products, one or more insoluble products, meaning you making like a solid in the middle of, like, you mix two clear liquids and then you make a solid, and it kind of makes chunks in a reaction. I think you're gonna get a chance to see it in the lab. But before you do it in the lab, we should know how to predict whether a precipitation is going to occur or not, right? We need to know that. And in order to know that, the only thing that, there's no way around it. We just have some general rules about precipitations, right? We have general rules about precipitation. So if a compound has sodium, potassium, or ammonium in it, it's going to be soluble. And if it's soluble, there won't be any precipitates, right? So that means that, for example, this compound that we just made that has sodium in it, NaCl, is going to be soluble in water, right? There won't be any precipitates. If you have nitrates or acetates, we're also going to be soluble, right? Then if you have chlorides, iodides, and bromides, we are usually soluble, except when you have these 3 metals: lead, silver, and mercury. All right. So that means that if something has a chloride like NaCl, it's going to be soluble. But if you have lead, for example, PbCl2, this is going to be insoluble. Okay. And then carbonates and phosphates are usually insoluble, right? An example that I always give is like chalk. Chalk is calcium carbonate, and it's not soluble in water, is it? Uh, and of course, the exception is sodium, potassium, ammonium, because these three are soluble, right? Hydroxides and sulfides are also soluble. Now, of course, there are other rules as well, but these are more general. And I'll tell you right now that, I'm going to give you an equation, and then I'm going to ask you, like, hey, does this equation produce any precipitates? And in the exam, I actually give you these rules. I just need you to know how to use them, but I actually give you the rules. But let's look at the equations that we've already made and see if. So the equations we've already made are, for example, this one. Does this one have a precipitate? No, because it has a halogen. Right? It has a halogen, so there is no precipitate here. Or this one, we also have halogens as well, no precipitate. Let's look at another example. So lead nitrate plus NaCl is going to be lead chloride plus sodium nitrate. But look at this. Lead chloride, we already established that it's an example of something that is insoluble because it's a part of the exception. So this reaction is going to actually produce a precipitate. Now I can ask you, right? These are a good question. So let's do one of them. I can ask you to predict whether or not we're going to have a precipitate. And guess what? In order to do that, you're gonna have to work it out. So let's start with potassium chloride. And I gave you a formula here, meaning that you have to figure out I gave you a name. You have to figure out the formula. Potassium chloride, and remember, before you write it down, you have to write down the cross rule. Potassium has 1, chlorine has -1. So potassium chloride is just going to be KCl here plus silver nitrate, right? Silver nitrate and silver can have different rules. We looked at it. It's one of those in the periodic table that can have different. Let me see the periodic table. You can have different charges, right? You can have one or two. But here, let's go with one to just make it easier. Ag, and then you have NO3 negative. And look at this. This one is pretty easy because Ag is +1, NO3 is -1. If you do the cross, it's going to be AgNO3. And these are our reactants. And then after that, you're like, okay, what type of reaction is this? Well, it's two things plus two things, so it's a double replacement. And how does a double replacement work? Well, this one is going to bind to this one, and then this one is going to bind to this one, all right? So we're going to start with Ag and chlorine, right? Ag and chlorine, and remembering that before we write down the results, we got to figure out the formula. So you have Ag here, you have Cl here, so you have +1, -1. So this is just AgCl. And then you have potassium, which is KNO3. This one is easy because they all have one, but they won't always have one. So it's -1 and +1. So this is going to be KNO3. And then the question is, do these are going to form a precipitate? Well, we learned about the rules, and we learned that halogens, right, chlorides, iodides, and bromides that have silver in them are going to be insoluble. So this will form a precipitate, right? This will not, because nitrates are soluble, right? Nitrates are soluble, but this will be a precipitate. So you have one precipitate, right? So this is how you predict a precipitate. But again, in order to predict a precipitate, you have to know how to actually predict the results of a reaction, right? And again, we looked at acid-base reactions, and acid-base reactions are pretty much kind of like, they're double replacement reactions as well. They are the same as double replacement reactions. The only thing that makes them special is the addition of an acid to a base. And another thing that makes them reaction special is this H plus OH produces H2O. All right, but they're still the same. Okay, they are still the same. Um, Oxidoreduction reactions, again, these are the ones that transfer electrons. Zinc loses 2 electrons to become zinc 2 plus, and then copper gains those 2 electrons to become copper solid. And we won't talk too much about it. If we have enough time in the semester, there's a chapter that we can talk about them, but um, those are oxidation reduction reactions, right? And other reactions that we looked at were combustion, right? You gotta be able to predict combustion, then you gotta be able to predict corrosion as well, all right? So these are the 8 reactions that we definitely need to know, right? We need to know how to do these, and we need to predict them. So if I give you an example, like, okay, we looked at this one, this is a combination reaction. Look at this one, this is a single replacement. This is an example of a double replacement that is also a what? A acid-base reaction, because this is an acid and this is a base. And the way these work is the hydrogen is going to go with the OH, right? And then the K is going to go with the NO3. So this one is going to be that K and NO3. And again, before you write it down, you got to figure out the formula. So NO3 negative plus 1. These ones are just going to be KNO3. And then for this one, you might be writing HOH, but remember, this is an acid-base reaction. Another way to write down HOH is H2O, right? So this produces water. H2O is what we use instead of writing down HOH. If I ask you, okay, what's the type of this reaction, and then predict the results? The type is going to be, this is a hydrocarbon or something with a carbon on the hydrogen plus oxygen plus a spark or a flame or something, is going to give you CO2 plus H2O, right? CO2 plus H2O, all right? And get this, even if I say C2H5 plus O2, what's the result? CO2 plus H2O. If I say, what about C10H, I don't know, 22, what's the result? Plus O2 is going to be still CO2 plus H2O, right? This is a combustion reaction. The only thing that's going to be different is we're going to have to balance it, and they balance differently. But they're going to be the same. So you need to be able to recognize a combustion reaction. All right, what about this one? What type of this reaction is it? Well, it's two things plus two things. What do we know about that? What's the type of reaction is that? Double replacement. That's correct. And double replacement, we know how double replacement reacts, right? Outside goes with the outside, inside goes with the inside, right? So it's gonna be, oh, we've already done this, haven't we? Mg is gonna go with Br this case. Mg has plus 2, Br has -1, so it's gonna be magnesium Br2, and then Na is gonna go with Cl. Na is plus 1, Cl -1, and then it's gonna be NaCl, right? One thing that you notice is that whenever we write formula and how formulas are written, the metal comes first. So remember that the metal comes first. When you're confused about which one comes first, the metal is going to come first. All right. So again, now you know how to tell what type of reactions there are. Again, we have 8 types of reactions that we've looked at. And you should be able to, when I give you two things, tell what type of reaction it is, predict the products based on what type of reaction it is, and then you can tell me whether or not it's going to give me a precipitate. Now, when we're predicting the products, we have to remember two things. Number one, remember to do the cross rule before you write down your product. You have to do the cross rule so that you can find the correct formula of your product. Very important. Another important thing is you have to remember the diatomic ions. You have to remember that these, not the diatomic ions, the diatomic atoms. You have to remember the diatomic atoms, and you have to remember that they are not, they are not by themselves. Okay. So by that, and the diatomic atoms are this, the diatomic elements. They are here and they are here, and you should be able to know them so that whenever you see it by itself, it won't be by itself. Whenever you say, oh, oxygen plus hydrogen, it won't be O plus H. It will be O2 plus H2, okay? And that should be enough. That should be enough for today. That's enough about chemical equations, chemical reactions, predicting and naming and classifying chemical equations. So go ahead and watch this video, replay it, and then practice with the practice worksheet that I gave you, and you should be fine. I'll see you next time. Bye bye.